Hello, and welcome to podcast.drchuck.com. My name is Charles Severance, and I'm the host of this podcast. This podcast is recorded and broadcast live on YouTube. About once a month, I have live open office hours with my online students on Coursera and other learning platforms. Each month, I come up with a topic to talk about for 30 to 40 minutes, then spend the rest of the 2-hour live event as an Ask Me Anything, answering whatever questions come up in chat. You can find either the previous or next live event at live.drchuck.com, and you can find my YouTube channel at plus.drchuck.com. And my online programming courses are available at online.drchuck.com. Welcome to the podcast. Hello, everybody. Welcome to the live stream. It's the first live stream. I've got a whole bunch of gadgetry. In a future live stream, I have a handheld camera, and I will show you how it all works in my studio. Hopefully everything is running well. I'll just I'll just talk a little bit, and then I'll start with the presentation. Let me get my slide queued up here. There we go. Start with the presentation. So let's see. This part of what this talk is I gave this talk a number of times in India. 10 days, 5 cities, 9 schools, 3 companies, and it really is to launch the C Programming for Everybody specialization on Coursera, which is my specialization based on this wonderful book by Brian Kernighan and Dennis Ritchie. And so I spent 4 years on and off building this course, and I wanted to go to India. India is about 1/3 of the technical demand for courses on Coursera, and so that meant a lot to me. I went to, like I said, a lot of universities. Here's a plaque. I've got a couple of plaques to go put on the back on the wall after I get done with all this stuff. I'll put the plaques up. So the outline for this is that I'm going to give a presentation for about 30 minutes, and then I'll just stop for questions and answers, and I'll be looking at the YouTube chat for the questions and answers. Okay. So without further ado, let's go ahead and get to the materials. Let me set my screens up here. Yeah, there I am. I like to put myself in the lower corner. There we go. So welcome to my talk on a programming career for everybody, navigating the path to mastery. My name is Charles Severance. I'm a professor at the University of Michigan School of Information, and I teach the world's largest programming class, Python for Everybody. A lot of you have probably seen my Python for Everybody class. It's really very, very impressive and meaningful to me how many people come up to me and tell me how their lives changed because they took a Python programming class. And as you'll see in this talk, I want to get to the point where I'm creating even more sophisticated programmers. I've gotten pretty good at creating beginning programmers, and now I want to create what I'll call master programmers. So here we go. I have been doing this online, on TV, on whatever, for a very long time, since I even had hair, right? And so back in the late 1990s, I was on television. I really wanted to take what I loved so much at that time was my computer science education, the emerging internet, and I just wanted to demystify it for people. I wanted to show people how it could be used and how this internet could be used. And my co-host Rich Wiggins and I, we basically spent all of our time saying, this is easy, this is easy, this is easy, you can do it. So before there was the term influencer, I just wanted to be a television-based influencer. And my YouTube channel, DrChuck, is hit 100,000. Pretty soon I'll have 100,000. The YouTube plaque is on the way. And I've started this new DrChuck Plus, and if you're watching this video, you are watching it on a DrChuck Plus. And the idea of DrChuck Plus was my main channel, youtube.drchuck.com, people expect that to be educational. They expect there to be no ads. There are no ads. I make no money off of that channel, even though there's 100,000 subscribers and tens of millions of hours of viewing. because I believe that education should be free. So plus.drchuck.com is just my fun place, and it's where I'm going to do these live things so as to not clog up my other channel. Where if you want to subscribe to youtube.drchuck.com, do so to get, like, when I put up a new lecture for a new class that's, high quality curated content, that's going on youtube.drchuck.com. If you want to see what I'm doing with a race car, you can go to plus.drchuck.com. I'll try to keep my post to one a day on plus.drchuck.com. So the key in this talk, it's really a tale of 10 years and 2 textbooks. I don't even have a copy of the other textbook, but I already showed you the first textbook, which is the C programming language with Brian Kernighan and Dennis Ritchie. And the other is the Python for Everybody textbook that I wrote in, am I seeing myself here? Yeah, there we go. My Python for Everybody textbook that I wrote in 2008, 2009, and then went on to Coursera in 2013. And so it's important to understand why I name everything, at least so far, with the word everybody in it. And I've always wanted to outreach the average person in the public, and I just want to teach everybody. I want everybody to know what the joy that I feel when I write software and build cool things. And so everybody can go all the way from a 13-year-old who just took a Scratch course and they want to learn something a little more deep, all the way up to a retiree who was a lawyer their whole life, and now they've always wondered what technology was, and they want to take a course. And so this has been a journey. When I was in India, for example, I talked to a lot of people in India, and it was surprising how many older people would say, "Chuck, I took your course." Like presidents of universities, chancellors and pro-vice chancellors, those folks would be like, "I took your course." And I'm like, wow. And so it's not just college students taking these courses. It's people in all walks of life who understand that if you're going to be a university president, you actually might want to know something about programming. Because increasingly all the students, a large fraction of the students want to come and take a computer science or programming or whatever. And so if you're a college president and you don't have a good understanding of computer programming, you need to fix that. So that's where everybody comes in. It's just there is nobody that shouldn't know something about programming regardless of where you're doing. So the most popular programming course in the world, the most successful with over 3 million graduates, 1 million of which are in India, was created in 2013, a year after Coursera was founded. It is now the most popular programming course in the world, translated into lots of languages. You don't even have to install Python. You can do it all in the browser. And it has all these auto-graded exercises, and it's way more than a course, because for me, I want you to understand the human context in which we operate when we're doing software development. All these programming languages were built by people. And I also want you to understand that there are other students around the world who are also taking the same course material. And so part of its success was it was not a first computer science course, it was a first programming course. And when the Coursera came out in 2012, 2013, it was very exciting times, and lots of schools and their computer science departments rushed to build specializations and courses. But they all just took the material that was suitable for their on-campus computer science majors, and they just put that up. And the problem with doing that is that they kind of have lost the idea that some of the students coming into computer science, a lot of students coming into computer science, are actually pretty skilled already, and so you give them their first class, but it's really not really a first class. It's their third or fourth or fifth class. And so computer science folks say, like, here you go, let's start here, and most students go like, ah! So what happened was all these classes built by computer science departments aimed at, college students at Princeton or whatever, or Johns Hopkins, they realized that those classes didn't start at a low enough or basic enough level. So I basically became the de facto prerequisite to every technology course on all of Coursera, and the rest, of course, then is very much history. After the success of Programming for Everybody, I have since just built a series of beginning courses, whether it be Django for Everybody, Web Applications for Everybody, which is PHP and MySQL, or Database for Everybody, PostgreSQL. These are all classes that fit into the curriculum at the University of Michigan School of Information, and that I taught on campus. And so our goal is mostly to teach beginning programming classes. We're not really a computer science school. So as the years went by and I was assigned to teach various different beginning programming topics, then each one I just turned into a Coursera class, because I have a whole framework and infrastructure for building autograders, and every time I build a course, I kind of build it as a Coursera course, at least since 2012. And so, I get well over 1,000 students around the world, 1,400 in India alone, every single week that enroll in the course. And so I am feeling very successful I'm getting people started. But one of the more common questions that I get when I talk to students is, how do I get a job? And a lot of people can take one programming course that's really just a introduction to understanding programming, and they can get a job. Probably that was because the other skills that they're not getting a job because of their deep programming skills. They're getting a job because they're awesome people and they know enough to learn something in their programming, right? And so, they get a job and they didn't get hired to be a programmer, but they're going to become a programmer afterwards. And all I really did was I gave them the pieces that they needed to learn more stuff. And you'll see that as a recurring theme in this. And I get asked so many times, how do I get a job? And one time I looked at that and I'm like, well, how about if I change the question a little bit and ask a question about who would I hire as a software developer? And I have a number of people that I've known throughout my years. Most of them came through the Sakai Project. They're some of the brightest and most brilliant programmers I've ever known. And if I was starting a company and with an unlimited budget, these are exactly the people that I would hire. Now, if I look at the inventory of all the people that I would desire to hire if I could afford them, a lot of them don't even have computer science degrees. They're not the most educated. They don't have PhDs in computer science, of course not. They're not the smartest people. They're not like geniuses. And let me define genius a little bit. So for me, genius is like, I've got the highest LEET code score. LEET code score is a almost athletic kind of programming that measures the pure horsepower in the engine that's inside your head. And I think it's a terrible measure, because people who are the best at those kinds of sort of deep internal mind things, those are often the worst people to work with. And so that's what I mean by they're not brilliant. They're wonderful, they're talented, and a lot of these people gain their experience working on large, extremely complex projects, and they love working for people. So I'm like, okay, I kind of know what I don't want from a potential new hire. And then I start looking at, like, is my new hire a sum of just whatever, 35 or 40 different skills? Because I want them to work on my thing. And is my thing React, or is my thing Objective-C? Is it Swift? Is it Kotlin? What architect picked the weird set of technologies that is my company's stuff? Now, if it's my company, it's going to be really conservative technologies, but a lot of companies pick crazy stuff. And that makes it so that it's more boutique and cool, and if you're going to write it in Kotlin, then it better be cool, right? You can't just take an off-the-shelf COBOL program if you're going to write it in Kotlin. And so none of the people that I want to hire have the inventory of their current skills is not really what I care about. And so it's not what they know. It's not what they were taught in school, and it's not what they have gone to a boot camp and learned, or even taken a bunch of Coursera classes and learned. That doesn't automatically make you, having a whole bunch of Coursera certificates does not automatically make you a great programmer. And then I kind of get down to the following, and that is, it's not what they know, it's not how they were educated. The most important thing for someone that I want to hire and put in my organization and pay my hard-earned money to hire, it's how they learn. It's two aspects of how they learn. First, it's how fast they learn. So you take the people in my list of greatest software developers I know, and you literally can drop them, you can hire them as the CTO of your Chief Technology Officer of your organization, and they don't even need to know what technology you use. You hire them, and they'll be like, okay, what are we using here? You'll be like, oh, we're using Kotlin and MongoDB and Ruby on Rails and blah, some arcane set of things. And these people will say, okay, give me a couple weeks. And at the end of that couple weeks, and this is what I mean by quick, right? At the end of the couple weeks, not only will my best programmers know everything that they've been asked to know, they will potentially know it better than almost every single person on the team. And that's because they don't learn it as syntax. They learn it based on understanding. They learn it based on a deep, multi-dimensional, three-dimensional understanding of how computers work, how software works, how operating systems work, how runtime environments work. All of these things, how memory management works, how networks work. So you can't just write a line of code and go like, well, it looks like a good line of code and it passes a unit test. No. When you're writing powerful, sophisticated, rich, complex code, you need to be able to see all of the impacts. It's a very three-dimensional, abstract view of what you're seeing on the screen. So not only do they learn it deeply. They learn, is Kotlin, and I don't even know, is Kotlin a compiler or an interpreter? I don't know. But if you hired me to work on Kotlin within 4 weeks, I would know a lot about it, right? And I would study things that you might not even think. It's not just the programming languages, it's libraries, it's the runtime, it's these things. I might write simple little pieces of code, and I'm like, what happens inside Kotlin if you do this, that, or the other thing? Not that I want to learn Kotlin. So let's just think about this from the point of view of designing a curriculum. And we can think of this as designing computer science curriculum. We can think of this as designing a Coursera curriculum. We can think of this as what kind of investment would we make in our current employees if we wanted to up their game. And so let's start with this. Let's start with this long list of all the possible things that you might go into a brand new job without much awareness. You'll walk into this brand new job and just pick from this list. Just pick 3 words off this list, and that's your job. And the question becomes, if that's how the world works, that every job you take, there is 3 random things from this slide that are the things you got to know. I can't put you in college long enough to teach you every one of those things. And if I kept you in college for 10 years, and then you had all these certificates, as soon as you go into the job market, there's going to be something else. So it's not sufficient to just gather all the certificates. It's fine to learn continuously, and everything you learn fills in gaps. So I'm not saying don't learn more things. What I'm saying is the quest is not to learn as many things as you can. I used to think that. I really used to think that if I learned all these things, then I could make the connections between all those things, and then I would know everything. So then I go through a different kind of an exercise, and that is, if I was going to build a curriculum, and underline the word I don't really trust computer science departments to build curriculums. I just don't. And that's because they have had curriculums for so long, and because of the demand in computer science, there's just no need to change curriculums. They don't need to improve their curriculum. They just need to kind of keep doing what they were doing 50 years ago, because no matter how badly they do it, an infinite number of computer science students show up. They teach the same slide deck they taught 10 years ago, and away you go. So I'm talking about a brand new curriculum, not constrained by the sense of what a computer science degree is. If you were going to create the perfect path to the master programmer who can do anything and learn anything in 4 weeks, what would be in that curriculum? And so you can probably guess that the first thing in that curriculum is going to be Python. Oh, let me take that out. Boop. The first thing in that curriculum is going to be Python. Oh, I can move myself up into the upper left-hand corner, or I could go in the upper right-hand corner. There you go. So the perfect thing, I think, is the first thing is Python. Why? Well, Python is increasingly the foundation for so many things like large language models, like big data. It's just like seems as soon as a new thing comes out, Python is sort of the first and most basic way to use it. And that's not saying that we'll use nothing but Python in large language models, but if you first see large language models, it's almost certain that you're going to see Python as the first language to kind of get you in. So Python is the welcome in, both for libraries and for programmers in general. So there is nothing wrong with learning Python. Learn it and learn it well. So the next thing that I did is I kind of pulled from this list and said, okay, what are the things that are really good from this list? And it'll come as no surprise, given that this talk is about C, that C is one of the things. Now, you might think that C is a good language to write code in, and I will tell you C is the worst language to write code in, absolute worst language to write code in. So I don't want to teach you C to teach you how to program in C. I want to teach you C so you understand everything. So Python followed by C, as we'll soon see, Python followed by C is to me the most powerful combination of programming languages to get you started down the path of understanding computation in general and understanding the complex, multidimensional world that is competent and high master programming. The other one I added here is SQL. It's really hard to imagine that anything worth doing doesn't sooner or later touch a database. And then architecture and assembly. And I don't mean architecture and assembly like so that you can be a complete hardware developer. I mean, I want you to know what a gate is and how an OR gate works, stuff like that. And so hardware is important to understand, but it's not important enough for you to be able to build hardware. I want you to be able to build hardware. I don't want you to be able to build hardware, but I want you to understand it. So if you look at these things, Python, C, architecture, assembly, and SQL, think of those as like 3 college credits. So that is about 12 college credits. You could think of it as 1 semester. It's kind of a long semester. You could also think of it as 10 hours a week for a year. And so there's a lot of ways you could take this 4-course curriculum. And then I thought, okay, given if these are the super foundation, are there other skills that we could build on top of it? And these things in these boxes are the classes that I want everybody to learn. Every single person, I think, needs to learn these things. Every single software developer needs to learn and master these 7 skills. And so at this next level, HTML. People think that you are born knowing HTML, and probably most of the people watching this do know HTML, but I'm just saying it's important. JavaScript is also important, because if you look at all the things above the line, you're like, okay, what things if you're going to learn Node or React or Angular, well, you need JavaScript. And so I'm not talking about a React class. I'm not talking about an Angular class. I'm talking about a foundational JavaScript that's just JavaScript. What's a browser? How does asynchronous stuff work in the browser? So that when you get to jQuery or React or Angular, you're like, I got a lot of basic knowledge. And at some level, we need another language beyond JavaScript and HTML. And I have chosen Java here, although you could probably put any number of other sort of higher level languages. These have to be memory safe, they have to be object oriented. And so certainly if you said, okay, I don't want to do Java, I want to do C#, I would not disagree with you. For me in my curriculum, I'm an open source guy, and so I just don't enjoy using the Microsoft stack, but a lot of people in business do. And so if you were to say, nah, let's not do Java, let's do C++ or C#. C++ is, there's some argument in the world as to whether C++ is a memory safe language or not, because the U.S. White House came out with a kind of soft directive that said people should stop using memory unsafe languages. It means C is a memory unsafe language. C++, in most people's book, is not a memory safe language. Rust is a memory safe language, meaning that if you over-reference an array, you don't destroy it or introduce a bug. But C++ is arguing, including Baron Strostrup, the inventor of C++, is arguing that the latest versions of C++ have the possibility of being memory safe. I'm not sure that's a strong enough assurance. C++ has historically been a high performance, embedded kind of a situation, and it does a good job at that. And the notion of it being memory safe, maybe, I'm not sure that memory safe maybe is good enough to call it memory safe. But okay, be that as it may. This last language is probably needs to be taught in the context of some larger software development project. And so I talked to a company called KPIT in India that does C++ work for in-car software. And, it's 15 years ago they started with C++ and they got all these C++ libraries. So in that place you're going to learn C++. So think of this last one, this Java, is almost like your your boot camp in your company. And so the Java one is a bit of an overlap between where you're going to work and what you're going to learn. But in that, it should talk about object orientation, it should talk about inheritance and stuff like that. So I look at this, then I see 21 credits, which is just about a year. And I look and I got some of these things already. I've got Python already, I got C already, and I got an SQL class already that are kind of roughly the shape of the 3 of the first 4. Now I've got Django for everybody and web applications for everybody that aren't in my list. They're kind of in the 3rd tier of things, but I got them, so they're there. And so what I'm trying to do is I'm trying to restructure my course offerings so that I have the foundations covered. And so the first class that I'm building is this class that I call C Programming for Everybody. And the text here that you can't see because it's the wrong color is looking at Python through the C lens and then looking at C through a Python lens. And so my goal in this C programming course, C Programming for Everybody, is I want to make it so that you know Python better when it's done. Right? It's not something where I want you to learn C. I want you to use C to understand how the computer is used to actually implement Python, right? Which is very different than I'm going to go write C code. I want you to know what is, I can move this down here now. Boop. I want you to understand Python, and I want you to understand C. I want you to understand kind of architecture. I want you to understand memory. I want you to understand dynamic memory. I want you to understand object-oriented programming. I want you to understand a whole ton of different things, right? And it's not like this is the course outline, because this is a terrible sounding outline, like understand interfaces, different implementations behind an abstraction. No, that's a learning objective. The whole idea is to build a course that is delightful, that exposes new ideas, that is fun to do, and when you're done, you kind of go like, oh yeah, I kind of understand the difference between an interface and an implementation. So don't look at this as the course outline. So let me give you just kind of a sample course outline from this course, C Programming for Everybody on Coursera. So here you go. It's a C class, right? But we're going to learn in the course 4, we learn how to do building of objects in C. So object-oriented programming, a historical perspective. Those of you who've taken my courses know that I love history and I love making these like fake chalkboard things about what inspired what, etc., etc. There's of course a play on the movie School of Rock where he has the picture of all the rock bands on the chalkboard. And so the historical perspective is like we know about programming languages and we kind of have a history of programming languages, but object orientation as a pursuit kind of in a separate layer above above procedural languages, that's a separate thing that had its own history and its own inspiration and its own sort of experiments and its own language evolutions and all these things that happened in JavaScript and Python and C++ and Simula and Algol 68. These were all things that explored ways that we do object orientation, right? And so that's the first thing, is like just a historical perspective. Like, this has been going on for a very long time. And it turns out that C and C++ are more coordinated than many think, because Bjorn Strostrup was hired at AT&T Bell Labs in New Jersey after he graduated from college, and worked actually in the same hallway as Brian Kernighan and Dennis Ritchie. So there was a lot of cross-pollination and influence between C and C++. And you can think of the evolution of C from 1978 to 1984, which when the second edition of the book was given, that was heavily influenced by the demands and thought and the object-oriented thinking that's in C++. Then we see Bjorn Strostrup, and then we see an interview with Bjorn Strostrup, the interview of the inventor of C++, and he tells us a lot about the magic of C++. We're in a C course now, right? But we're learning about C++. And then the comparing object-oriented approaches, I talk about JavaScript, I talk about Java, I talk about C++ and Python, and compare all those things to say, look, object orientation is a really powerful concept, and yes, each of these languages takes a little bit different approach to it, right? And so that is just a sample of one of the weeks of 4 classes in the C Programming for Everybody specialization. Now, this is based on a very special book to me. It's not a book that you can buy. If you take a look, this second edition of the C Programming Language, this is the book you can buy. And it is by Brian Kernighan and Dennis Ritchie, and it's the 1984 edition of the book, which still you can buy in print. And so this is the book that most of you bought and used when you took a C class, and lots of you have. I think you've taken C classes, you've just taken the wrong C class. So you took a C class that had a different understanding. Well, its goal was different. It thought it was just teaching you programming, and that's fine, because you do need to learn to program. It was a first programming class in a lot of curriculums. Or C++. If you do bad Java, C++. If you do kind of mediocre C++ and you don't really understand C++, it's a fine first programming language, except I think it's a bad one. I think Python is better. So the book that I use in this class is C Programming Language from 1978. It's a more raw book. It's not as polished and sophisticated as the 1984 edition. And what I like the most about it is the authors break the fourth wall when they are talking in this book, right? They will tell you why they did certain things in C, and they'll just explain it. And they'll say, like, well, we did this other thing and the bit alignment wasn't right, and so in the interdata 732 we did this other thing, and that's why structures are the way they are. And in the 1984 book, they don't say that. They don't ever break the fourth wall. And so the other thing that's kind of going on here is 1978 is the moment where everything changed, right? Everything before this book, before the C Programming Language, every time that we would buy a new computer, you'd have to just go learn a new programming language, because different computers liked different programming languages. And, and so different hardware architectures the programming languages were well tuned to different hardware architectures. After C, we wrote in one language, and I'm talking about operating systems and low-level utilities. Python itself was written in C, and then now we can write in Python instead of writing in C. But portability across multiple computer hardware vendors and across multiple generations of computer vendors became possible because of C. And then we wrote more portable things on top of C than they were portable as well. And so in 1978, everything was changing, and you could think of this book, this C programming book in the 1978 was like the announcement of the summary of 15, 20 years of research into software portability. And so it is an important time in our world, and that's why I use the 1978 edition, because I'm focused on understanding the nature of computing, and in the 1978 edition, they show the nature of computing. So, it's an online textbook. I digitized it. I thought I was going to get in trouble with Pearson, but since then I have talked to Pearson, and they're pretty happy with it. There's auto-graded assignments. It's a browser-based compiler environment. Just like the Python class, I did not want to. Just like the Python class, I did not want to force you to install a C language, because it turns out that when you compile C, you can tell it to do all these, emulate different versions of it, and I'm making it emulate the earliest version of C. That's not necessarily the right version of C that you want to use, and so I didn't want to fight with all that. If you're going to look at my code samples, I wrote in the antique version of C, and so I make the compiler do the antique version of C. So the book is free, and it's online, and it's HTML. I wrote it, I digitized it and had it turned into Markdown. And that means that those with limited vision, that blind and low vision students can use HTML as the best way for them to read, pretty much, because then they can move, effortlessly around in the book and see all the information that they need to see. And so we made it highly accessible, and that's actually just our benefit, right? If you go to the book URL, there's a code, and the code is 42 to unlock it, because when I first did it, I didn't want Google to find it in case Pearson would find it, and then I would get in trouble, so I hid it behind a code. I think I don't have to hide it behind a code, but I still think it's fun to hide behind a code. So there's a Easter egg, which is the code that you get to redo this. It has a built-in C compiler. This C compiler is kind of weird in that it uses a server to compile it, but it doesn't use the server to run it. The danger in building autograders is if I use the server to run code that students write, then those students can try to escape my sandbox and harm my server, run it out of memory or crash it or change grades or delete files or whatever. And so the code doesn't actually run in the server, so I didn't have to build a padded cell to keep it safe. And so it just runs on your browser, and then the output comes back to the autograder, and the autograder looks at your output and decides if you got things right. So it's a pretty cool compilation environment. It's designed to handle hundreds of thousands of students pretty efficiently without too much server resources. Once I created the textbook online, I decided that I would also read the textbook. And so you can subscribe right now as a podcast to audio.ccforE.com, and you can just listen to the book if you find it interesting. I only did up to chapter 6 because chapters 7 and 8 get a little bit dense, and so that's not too much fun to read the pages and pages of code in chapters 7 and 8. This is available on Coursera, but it's also available for free for other teachers, for students who want to do review long after they took the course. I also want to make it free and publicly available because then search engines and increasingly large language models can look at this stuff, and you can just start asking questions, and maybe you'll find yourself to the front end of my YouTube videos. So I make sure that everything I do is also public, and it's also Creative Commons attribution, and it's on my YouTube channel, the DrChuck YouTube channel, and it has no ads, right? So there's stuff that shows up that YouTube puts up no matter what, but I have turned ads off on all this material. So if you are a teacher and you want to use this material, you get to use it for free. So another thing that I always put in all these courses is interviews. As I showed you, there's a lovely interview with Brian. There's 2 interviews with Brian Kernighan, and there's an interview with Bjorn Strostrup. And I am currently working on, and we'll add to the class soon, an interview that I did with Guido van Rossum, where I talked to Guido van Rossum about the approach to object orientation inside of Python. And what's cool is that I wrote So I wrote, at the end of the last class, you're building a string class, a list class, and a dictionary class. Remember I say look at Python through the lens of C, and look at C through the lens of Python. So you build these things, and I built them based on chapter 6, wherever that is. Chapter 6, that's chapter 8. I built them based on chapter 6 of this book. Right, so, chapter 6 of this Kernighan and Ritchie book. So I asked Guido, I said, Guido, did you use chapter 6 of the Kernighan and Ritchie book? And he said, no. I said, did you make linked lists? He said, no. I said, did you make hash maps with linked lists coming off of buckets? And these are all the ways that we computer science programmers think of. I've been using Python for years, and I just assumed that list meant linked list, and I assumed dictionary was hash. Hash maps the way we saw them in Kernighan and Ritchie, because we all learned it from this book or some derivative of this book, right? And he said, nope. He said, I found a algorithm in a different book, and that book that he found the algorithm is a book called, there you go, it's called Sorting and Searching, The Art of Computer Programming by Don Knuth. And this was an earlier book that had all the knowledge in it, and he used a technique from this book called open hashing, which is way, 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 way deep in the book. It's hard to find the part that Guido found to build dictionaries and lists, but he used the concepts in a much earlier book than Kernighan and Ritchie. Although he knew Kernighan and Ritchie, the book, and he learned from that book. He actually had known C++. And so the bottom line is that I'm going to add an epilogue to the course, which is basically me and Guido and myself reflecting on the actual implementations, which are different than the implementations that I did in the course. Because I did the implementations in the course the way that I did the implementations in the course the way I would have done them if I'd read the C Programming for the C book in Kernighan Ritchie. And that's what I did in the course, because I'm a computer scientist. We're taught this certain way of doing things, and I did it those ways. And Guido did them differently, because he's not really a formally trained computer scientist. He's not a computer science researcher. He was solving engineering problems, and it was not his first time building a programming language. It was like his second or third time, and so he had some real strong opinions about the right way to do it. And so what this epilogue will do is it will be me and Guido talking about how I did it based on Kernighan and Ritchie's book, and then how he did it based on his own experience. So with all that leads to the C Programming for Everybody, which to me is a course that is unprecedented. It is unlike any other programming course on the planet, as far as I'm concerned. It is a course that is to teach you Python. C programming to get better at Python, and then Python programming to get better at C, so that when you're writing Python code, you're seeing deeply into things that are happening. So then I've got more classes that I want to build, and so the next class after this will be a computer architecture class, and I want to keep that as simple as I possibly can. These are the learning objectives. They're not exactly the course outline. And so I want people to know what electronic computer is, what's a gate, what's inside of a chip, how do CPUs work, machine language assembler, compiler, runtime environments. And so this sounds like a hard course, but I'm going to make it as easy as I possibly can and fun as I possibly can, and just make it so that it's as engaging and that I can get to those learning objectives without sort of beating the students up too hard. I want to make it for everybody, hardware, computer architecture for everybody, and in doing that, I want to, really figure things out.
We hope you enjoyed this episode of the DrChuck Plus podcast. To find out when the next live event is, visit live.drchuck.com. To find Dr. Chuck's YouTube, visit plus.drchuck.com. And for Dr. Chuck's online courses, they can be found at online.drchuck.com.